Okay. When you're done, you send me, okay? The
Use
molecule of
use
fluorine.
PDF is it? Yes.
Sorry?
Use PDF ah.
Anything, it doesn't matter because it's just one picture.
Oh, then I should use WhatsApp lor. Send liao.
All right. You forgot something. Okay. Now you need to remember. Okay. The electrons have to be shared in the middle. So this one must draw like this. Okay. Now, if chlorine is like this, will fluorine be the same? Look the same? The outer shell?
Yes.
So chlorine, bromine, iodine, astatine. But astatine is radioactive, so we don't usually talk about it. We talk about the first four. Okay?
Astatine.
Astatine. This is in natural state. Natural state means at room temperature pressure. So at room temperature pressure, fluorine is a gas. Okay, chlorine is a pale yellow-green gas. Can you check this out? Fluorine is a pale yellow gas. Okay, but the most important are these three. Chlorine is a pale yellow-green gas. Okay? Wait. Then bromine and finally iodine. We focus on these four. Bromine is a red-brown liquid. And finally, iodine is a grayback solid. So as you can see, what is the pattern here? Gas, gas, liquid, solid. It becomes more and more solid. Correct now. So that means the melting point and boiling point going up down the group. Okay, this is its natural state at room temperature pressure. You can see the color changing. Yellow, yellow green, red brown, gray black. So it's getting darker as you go down. So that's the trend. The melting point goes up and the color becomes darker. Now, do we use chlorine gas, bromine liquid, and iodine solid in the lab? No, we put it in water. When we put it in water, it's called chlorine water, bromine water, iodine solution. Do you remember? Okay, we call it chlorine water. That means chlorine mixed in water, of course. But we still write it as Cl2. This one not important. The color is very pale. These two are the important ones. We call this bromine water, and the color is orange. For iodine, we call it iodine solution, and the color is brown. Remember the one to do starch test is brown?
Yes.
That's why, because it's iodine solution.
So I2 exists as a solid naturally.
Yep. In order to use it, we dissolve it in water. Okay.
Okay.
Another way we use it is, as we have learned, as an ionic solution or ionic compound. When it's aqueous. So for example, sodium chloride, potassium bromide, potassium iodide. These three have what in common? When they are solution, what's the color? Colorless.
Plus.
Okay, can? Okay, so remember, they don't call it natural state. They will say at room temperature pressure. Okay? For this one, they will say room temperature pressure.
Okay.
So going down the group, the melting point and boiling point increases, the density increases, the color becomes darker, and the reactivity decreases. Okay? Group 1 reacts by releasing electron. Group 7 reacts by receiving electron.
NaCl is just stable salt, right?
Yeah, but it's colorless solution.
Oh, interesting. Salt. Okay.
Now, what happens here is the ones that are, okay, so this is what we mean by reactivity. Chlorine really, really likes to receive electron to form chloride. Okay? Chlorine really, really likes to receive electron from chloride. Now, let's say they really, really love to do this. Okay? Because it's the most reactive. Now, let's say I have a solution of potassium iodide. Okay? Can? Can you
Yes.
write me the formula for potassium iodide? What's the formula for potassium iodide?
K
Huh?
plus
No,
K.
no. Just the formula.
Oh,
What is
Ki.
formula? Okay, in Ki, what is the ions in Ki?
Potassium and iodine.
So K positive and
Positive and
I
I
negative.
negative.
Okay. What is the color of the solution?
Purple.
I just told you 10 seconds ago.
Wait ah.
It's still in your notes. I told you 10 seconds ago.
Wait ah. No, no. Yellow, brown.
ZiHua, potassium iodide solution. I told you the answer 10
Colorless.
seconds ago. Thank you. Colorless. Okay. Now,
Yes.
I add in chlorine water. What is the formula for chlorine water?
Chlorine and water.
No, I told you it 20 seconds ago. Can you please look at the table I gave you?
CO2.
Yes. Okay. Now, who is more reactive? Who is more reactive, chlorine or iodide?
Chlorine.
Chlorine is more reactive. So can chlorine steal the electron?
Yes.
So what will happen is chlorine will steal the electron to form chloride. Now iodide will have to give the electron. Can you see this?
Yes.
So this kind of reaction of chlorine taking the electron is called what kind of reaction? This first one?
Reduction.
Yes, very good. Reduction. Then what is this one?
Oxidation.
Okay. These kind of equations are called what kind of equations?
Redox.
Half equations.
Oh, half.
Okay. Now,
Yes.
can you combine the two half equations together to become an ionic equation? So you take chlorine plus 2 iodide become iodine plus 2 chloride. This is called ionic equation. Okay.
Okay. Okay.
All right. So now, overall equation. So you put everything together. This is overall equation. Okay, this is called a displacement reaction. Who displaces who? Can you tell me who displaces who?
Chlorine displaces iodine.
Yes, no. So we say chlorine
Oh,
displaces iodine. Okay,
okay.
now what is the color change? Your eyes
Color
are looking at the test tube. What color change do you see?
colorless to brown. Colorless to brown.
Colorless to brown.
Brown.
Correct. I'm going to draw for you a few, I'm going to write for you a few things. If I want you to write down the half equation, the overall equation, the ionic equation, and the color change. Can you understand? Basically, everything I
Yes.
just did lah. So how you understand?
Yes.
So question one. Okay, you know what to do?
Yes. Miss, need to write the equation only, or need to write like the color.
D. That means same as what I did just now.
Ah,
Half equation, oxidation, reduction, ionic equation, chemical equation, and color change. Everything. When you're done, you send to me, okay?
okay.
Who are you done?
Almost like the last one.
Okay.
Miss,
Yes.
for the last question, right, is it everything no?
Then you just write no reaction, huh?
Oh, okay. I've been thinking for quite a while. I thought confirm got reaction.
Why? You must think first, what? Let me see your answers. Wait, that's the one I download, ah. Hmm. So the first one. This is number one, ah. This is number one, is it?
Yes.
Wait, ah. Okay, you see. Yeah. Huh? Korean. Okay. Plus electron. Okay, this one was reduction. You Emma, you eat, yeah. You ate already. Thank you for thinking of me. Oxidation. Right. Okay. Chlorine plus sodium bromide becomes bromine. Okay. You forgot ionic equation. You forgot ionic. Okay. Colorless to, not brown, colorless to orange. Do you know why? Do you understand?
Yes. Okay, let's look at the second one. Potassium iodide, bromine and potassium iodide, potassium bromide and iodine. Okay, so the ionic equation, iodide plus bromine becomes iodine and bromide. Okay, what is the color? Taught you just now already. From this color, it becomes this color. Colorless to what? ZiHua, think a bit. Iodine is not in this Brown.
solution. Ah, brown. I don't know where you get dark red from. I didn't teach you any dark red also. Okay, can. Right, and of course, this one, no reaction. So why no reaction? Because bromine is more reactive than iodine. Okay? Do you understand? Okay. So this is called displacement reaction. Okay, for this chapter, there's two more things I want to teach you. I can't finish it today. Okay. The first thing, but I'll teach you this next week. Remind me to start with uh, next week. Remind me to start with transition metal. Okay, we continue. Last one is transition metal. Then we are done with this chapter. Okay, let me teach you one more thing, which is noble gas. Noble gas is group A. So in group 8, it doesn't have to have 8 valence electron. Helium has only 2. Neon is 2, 8. Argon is 2, 8, 8. Basically, it all has to have full outer
Oh.
shell.
Ha. Oh. Oh.
And then when it has full outer shell, because it has full outer shell, it is unreactive, monoatomic gases. Okay, do you understand what it means by monoatomic?
No.
Mono means one. Monoatomic means one. So they all exist as atoms, atoms, atoms like that. As a gas, but atoms. As compared to group 7, they exist as diatomic. Okay. Group 7 exists as diatomic. Can you see the difference?
Yes.
Okay. Now, next week, I will teach you the last part. We can't do it in 2 minutes now. Okay. Where we're going to talk about the difference between group 1 versus transition element. Okay, they are both metals. Well, how are they different? Let's talk about how they are the same first. How are all metals the same? All metals can conduct electricity,
Electricity.
correct?
Yes.
What else can they do? Can conduct heat. They are shiny.
Um,
They are
high,
malleable, and they are
hi-
ductile.
uh,
Okay, right. Next week we will talk about how they are different and then why they are different, and we'll talk about some past. We will do some past year paper questions. Okay. How come your exam